Part 2 of Algebra 3, Test 18 review, picking it up with question number 11. I'm guessing that we just want to go ahead and cover all the rest of them from here on out. Is that correct? All right, question number 11, find the range, mean, median, mode, and variance, standard deviation of the following data. I don't know that, again, that's probably something that we need to do, because what are we going to do? We're going to go into our graphing calculator, we're going to hit stat, we're going to fill in the list, and it's going to give us the bulk of that information. Just so that we have it up here, though, range is your max minus your minimum, right? Okay, so let's go over at least a little bit of this. Your range was 6 because, well, hold on. Range. Okay. Because what you have is 7 minus 1. Your mean, add them all up, divide by how many there are, which if you plug this into your stat list, is going to give you 3. Okay. Let's see. After that, your mode was 2 because it shows up the most. And let's see. The next thing, this is what you actually do want your graphing calculator for, which is your standard deviation. And your standard deviation here is 2. Is that what you guys got? 2 is your standard deviation, which means we're going to square that to get our variance, which should be 4. Okay? Variance is 4. Oh, did we not do median? Okay, I'm sorry. Median. Maybe I looked at the wrong thing. Nope, median is 2. Okay, and that's obviously where we put our data in order, but that will still show up in your stat list set of data, right? MED. Okay, so those are our numbers. I'm not necessarily looking for how you found all of them. Granted, your range is one that it's probably not going to give you in that list. Mean it will. Mode, I don't think it does. So you'll need to, that's not hard. You don't even have to show me any work there. Median is going to be in there. But I would like to see how you got your variance, right? Because the biggest mistake that people make is finding the square root of their standard deviation instead of squaring their standard deviation, okay? All right, number 12. Slide back over here. Number 12. 2 times the supplement of an angle exceeds 5 times the complement of an angle by 69. What is the angle? We haven't seen a question like this in a long time, right? But, when we did, they were frustrating, right? People struggled with them. 2 times the supplement of an angle. So 2 times the supplement of an angle would be 180. 2 times 180 minus x, right? That's how we would show the supplement. So 2 times the supplement of an angle exceeds, all right, so it's going to be greater than 5 times the complement of an angle. So 5 times the complement of an angle is 90 minus x. Okay, and we're exceeding this by 69. So I have an option. I can either subtract 69 from the left or add 69 to the right. I'm going to add 69 there, and then I can set them equal to each other. But I can't set them equal to each other with exceeds in it, so I have to fix the exceeds portion. After that, we have 360 minus 2x equals, let's see, what is that, 450 minus 5x plus 69. 360 minus 2x. What's 450 minus 60, or sorry, 450 plus 69? 519. Minus 5x. Let's see. Easier to add 5x because that's going to give us a positive x. Subtract 360 because that's going to give us positive numbers on both sides. That's going to give me 3x equals, what's 519 minus 360? 159. What's 159 divided by 3? 53 degrees. 53 degrees. All right, go back and check on number 12, 53 degrees. Any questions about that? Okay. Hardest part to that is making sure you do the right thing with the 69. Okay? All right. 13. 13, solve this triangle for the unknown parts. 30, what's 30, 70? And an unknown. There, we've got angle A, B, and 10. This should all be able to be accomplished with law of sines. Now, the first thing I would probably do is determine angle A. Angle A is, what, 80 degrees? Okay, 30 plus 70 is 100. Subtract that from 180, it's going to give you 80. Okay, so we can go ahead and fill in our 80 degrees there. All right, and then the rest of it's law of sines. So sine 70 over 10 is going to be the one thing that we have to be able to use for both A and B. Equals, we can do sine 80 over A. What we're going to wind up with is 10 sine 80 divided by sine 70. Somebody want to tell me what they got there? 10.48. And did that match what was in the answer key when you looked at it? We don't remember. Let's double check. 14 or 13, sorry, yeah, 10.48. Okay. And then on our next one, which we want B, we're going to do the same sine 70 over 10 because both that set of data was given. I don't want to use stuff that's found if I don't have to. And then sine 30 over B. So what I'm going to plug in my calculator is 10 sine 30 over sine 70. What do you get there? What's that? 5.32? I believe, because I was just looking at the answer key, I believe that's correct. Okay, double checking, 5.32. So yeah, you just need to find those three things. Does that make sense? Okay, we remembered law of sines. Cool. 14. Try to get as much of this done before some of you guys have to go, or at least one of you has to go. Find the area of a triangle. It's a terrible triangle. Let's do something a little bit better than that. Okay, we got 60. All right, that should make life possibly easier, maybe not. 30 and 32 radical 3. Okay, all right, so we can choose our 32 radical 3 for our base, but we're going to need the height. So 32 radical 3 divided by 2. If this is 60, then this is 30. Let's see. Okay, because, all right, so we would get 15 down here. We'd get 15 radical 3 there, correct? All right, so then I just need to do times 15 radical 3. Okay, 32 times 15 times 3 is essentially what it's going to come out to. Because our radical 3's are going to multiply by each other. That was a nice save. Times 3, and then divide by 2. Should get 720, right? And meters squared. Okay, does that make sense? All right, so you do. Now, what you might need to do if you don't, if it's not given to you as a 60, I'm trying to look. Yeah, you're going to be fine. You're going to be able to use a 30, 60, 90 triangle or a 45, 45, 90 triangle, and the other one is on the test question as well. So you can do this without using sine or cosine, which you would use sine for it anyway, right? Okay. 15. 15, graph the solution to the system of inequalities. All right, so if you look at the top equation, x minus 3 squared plus y squared is less than or equal to 4 squared. That is the equation of a circle where one of the coordinates is 0. So what we're going to end up doing here is let's make 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So you should be able to look at that top equation and see where the vertex is going to, or where the center is going to be. It should be what, to the right 3 up 0? Is that right? Okay, 1, 2, 3. So that's the center of the circle. It should have a radius of 4. Is that correct? Okay. So 1, 2, 3, 4. 1, 2, 3, 4. 4. About there. So something that looks pretty much like that, and that is probably the best circle I've ever graphed. So
You drew the best circle yesterday.
I know I'm getting really good. All right, all right. So the next thing you want to see is that our shaded region. It's saying that the radius is greater, or I'm sorry. You want to go whether or not the left-hand side, your circle is greater than or less than your radius. Because it's less than the radius, that means we would shade inside. But we want to wait to shade inside till we know where we're at with our parabola. And your parabola is the same situation. You can tell where the vertex is. Notice that it's to the right 3, but it's not up at all. Or the vertex doesn't move. So it actually opens up like that. Okay? But the shaded region is based upon the y, right? And it's less than that parabola. So what you're shading here is actually this, which, if we add some, kind of do.
The old time, I was thinking the old time, I thought that the blue looked like a mouth, and I thought the mustache, it was like a mustache sticking out.
Yeah, I was thinking, this would, like the blue was the teeth,
Yeah.
That kind of thing. So there you go. That's how to draw a monster using circles, parabolas, and shading. You're welcome. All right, number 16. Man, it's gotten really warm in here. All right, simplify. Let's see, we got A, B, and C, so let's start off with A. We have ln E minus log 10. Okay? Well, hopefully we know that the base there is 10, right? Which means, and we should know this, we should know that ln E is equal to what? 1. And log base 10 is equal to what? 1. So we got 1 minus 1, so our answer here is 0. Okay? B, how did we do on A? Did you guys get that as an answer? Cool. All right, then we've got log base 10 to the 4th plus log, let's see, 10 to the 1/4. All right, because these are log base 10s, right? So they're effectively 1 by themselves. So what we need to do is actually take these exponents and move them out front. And what that winds up with as we drop the log is 4 times 1/4, which is 1. Okay, did you guys get 1 as an answer on B? Let's see, let me look. What is this, 16? No, okay, so they're showing where it's just 4 plus 1/4.
Yeah, that's what I got.
Okay, so they got 17/4. So let's just, there, fixed it. Okay, so they don't actually multiply those. All right, good job, me. C.
Drop the log right through it and add it together.
Well, you're technically just leaving the logs, but cause that all to equal 1.
And then you multiply by the exponent.
Right.
Yeah.
Yeah. I don't really like that though, but you can't drop off the logs because you have brought the exponent in front of it. And because these are equal to 1, you're just adding 4 and 1/4. Okay, it's a little confusing there. Log base 416. And what's the other one? Plus 4 to the log base 45. Okay? All right, well, this part over here is just equal to 5. Okay, so log base, that would be log 16 divided by log 4. I'm curious on this. So log 16 over log 4, if we should be equal to 2. Okay, you can check if you have a new enough calculator, your log base, where you're doing 4 and 16 in there, and it comes out to 2. Or you could do it like what we see up here. So what we end up with is 2 plus 5 equals 7. So 0, 17/4, and 7. Okay, 17. I did look up like pictures out of context, but I was like, I feel like I'm getting too much out of this. Like, I feel like I can guess what some of this is referring
The
to.
very first picture on Google Images is one that you would not understand unless you've seen the movie.
Really?
I saw one. It was. I'm not gonna say it though.
Yeah, don't. Yeah, don't. All right, 17. Solve for x, and it starts off here with, can somebody read it? It's like 3/2 log 8 base 8 9 minus like that. Okay. All right. So looks like let's see. What I would do first is move the 3/2 up here, and then solve that. So 9 to the 3/2. So I can take my calculator and do that. 9 to the 3/2, and it should get 27. So this is log base 8 27 minus log base 8 x equals log base 8 9. Now everything's in the same base, so I'm going to do this as 27 over x equals 9, right? Multiply by x, 27 equals 9x. Divide by 9, x should equal 3, correct? Double check, make sure I'm not thinking wrong there. 3, okay, good. You guys feel like you did pretty good on the review, or did it make 18? Solve for x, we've got ln x plus what? Ln x plus 4 equals ln 5. All right, the nice thing about this is all the bases are the same, correct? So we've got x times x plus 4 equals 5, x squared plus 4x. We're going to subtract 5 minus 5 equals 0. We know we should get a 5 and a 1. Positive 5, negative 1. X equals negative 5 or 1. X equals 1 and not negative 5 because we can't, right? That would force it into a negative. So 1 is my answer. Number 19. Sketch the graph of log base 6x. You're going to wind up with something that should look, I believe, like that. Let's see. Let me look at a table of values. The locations where you need coordinates are at 1, 0 and 6, 1. Okay, so what I'm going to look for is a graph that looks generally like that, but I want 2 coordinates, at least 2 coordinates. Okay? Can you do that for me? Perfect. It's not a whole lot needed there. Last question, number 20. The magnitude of an earthquake in the Martian archipelago over the last 12 years has been approximately normally distributed. Okay, so this should be not too terrible. Okay, normally distributed with a mean of 2.5. Okay. Okay, 0.2. So 0.2 would be what? 2.7, 2.9, and what? 3.1. Okay, I don't know if we're going to need this or not, but let's kind of carry this on out here. 2.3, 2.2, or wait, no, 2.1, and 1.9. Okay, good. All right. What percentage of the quakes registered under 2.8 on the Richter scale? So we want to know what registered under this. Okay, so we typically know we would have we got 68, 95, 99. So we want to know what is from here over. Okay. So we're going to actually find our z-score for this. So our z-score is the number that we're going to use, which in this case is what, 2.8, minus our mean of distribution, which is 2.5, divided by our standard deviation, which was what, 0.2? 0.2. Okay, 2.8 minus 2.5 divided by 0.2. What do you get? Should get like 0.3 divided by 0.2. 1.5. Okay, so what we would do from here is we would go to our z-score table, and it would come out to like 0.9332. And for us, that's going to be 93.32%. Are you out?
Yeah, I was gonna say like you could use my shoes for a talking point.
There we go. Let's see. So remind me on Monday, and I will get a z-score table out for you. I'm going to check something real quick here to make sure. Okay. All right. But does this make sense?
Yeah.
This probably, if you did this, may have been, well, actually, everybody should have done it, right? So was this one that you guys might have missed? Probably. Okay. All right. Well, we are going to hit stop right there, and I hope that it recorded to the end because my mic is blinking like the batteries are dead.